So why don't we do a quick exercise with some different kinds of variables and just get you going using Unity. So let's do this. I'll go ahead and, with Unity already launched, I'll go ahead and create a new project. And I will call this variables. You can put it wherever you'd like. Wherever you can find it is what I recommend. But we're just going to call this one variables. And we're not going to make any cool new games today. We're just going to sort of play around with some of the basic things that you learned in the variables lecture. All right, so since we're not doing anything in Unity proper, the first thing we're going to need to do is create a script that we can edit. So we'll do this by going into Assets, and right here we have this area. We can just right-click, click on Create, and then find C# script. Make sure you select C# script and not JavaScript. They are not the same thing, and we really want to go with C# script. So let's do that. If you do it correctly, you'll see that the icon actually has C# in it, and we'll call our script variable script, just so that we can get going. So I'm going to double click this. You can see that it gives you a preview of what it looks like. I'm going to double click this, and that's going to open it in Unity. And I was fooling around with another project, and so this is actually for the advanced class. I'm going to click don't save because I was just fiddling around with it. And I'm going to go ahead and blow up the size on this so that it takes up a bit more of the screen so we can see a little bit more. I don't want the whole thing, but most of it. Pull it down to I know you can see that's the bottom, even though I have more monitor left. All right, so this is what we get as a basic script. I'm going to hold down Control and use my roller wheel to make this a little bit bigger. Oh, no, I'm not. There we go, it's Alt. Okay, so on the Mac it's Alt. On the PC, you hold down your Control key and use your mouse wheel to make it bigger. Okay, so on the Mac, again, Alt, PC is Control. All right, so just make this a little bigger just so it's easier to see. And we're going to make a few variables. So we're going to do this in Start. And we'll go over what Start and Update and all this other stuff in here means another time. But for this, we're just going to sort of fiddle around a little bit so that we can get comfortable with variables. And we're just going to use variables in the context of being inside of one of our methods. We're not doing anything object-oriented yet. We're just starting with the basics. So we're going to start in Start, and we're going to create one of each kind. So there are three basic kinds of data. There are numbers, there are strings or characters, and then there are Boolean types. And I'm just going to show you the ones that are most commonly used in Unity. There are dozens of them with different delineations as to how much memory it takes, how much space it takes up in memory, and levels of precision and things like that. All that's covered in the lecture, so we're just going to stick with the most commonly used ones in Unity programming. So we'll start with a string. A string is a collection of characters. It's not the same thing if you're coming from C or C++ as an array of char. This is actually a formal type in C# that allows you to manipulate a string as a collection of letters. It's just, you don't have to worry about size. You don't have to worry about redimensioning the size of the array of chars, anything like that. You can just say string, and then I'll call it my string. That's the name of the variable. This is completely arbitrary. I've had students in the past think that because I type my string there, it has to have the word string in it. It does not. I can make this whatever I would like to. John Jacob Jingleheimer Smith, that's my name too. And that shows you that you can make this whatever you'd like. I'm just putting arbitrary names in here, just trying to keep this interesting. So I'll call it my string example, and I'll set this equal to this is my string. There are many like it, but this one is mine. All right, so that is how you create a variable. So I've given it a name. I have proclaimed its type as being string, and then I've initialized it to a particular variable, or a particular value, rather. This is really how you want your code to look. You want to have your type, your name, and then you want to go ahead and initialize it. It isn't required that you initialize it. I can actually get rid of this part and assign it later. This is the same thing as declaring an empty string. And in the case of strings, you can do this explicitly if you would prefer to. And I prefer to do explicit things in my code. I don't like to have to guess. And I certainly don't want the person that comes in after me to maintain this, be that me or someone else, to have to guess, having, slept a few times since the last time I made an edit to my program. I can do this formally. I can say string.empty, and that's another way of initializing this if there's nothing in particular that I want to put in there. And then I'm going to show you something that's sort of unique to C#, and that is implicit typing. I'll tell you what, we'll put a comment in here. If I put two of these slashes together, I can say this is a comment, and what happens is our compiler will ignore comments. It sees that and it's like, okay, that's just, I don't have to do anything with that. It doesn't show up in your end program. Adding them doesn't make your program bigger. It's just something you put in there so that you can keep track of things. So you can use this to take notes. You can use this to put comments in there on a particularly, perhaps somewhat confusing piece of code, though hopefully if it's confusing, you go back and fix it so that it's not confusing. But sometimes you have to put some notes in there. And it's also used for documentation. So I'm going to add a comment that says this is implicit typing. Okay, so this is, again, a feature that is unique to C#. I can actually just type var here instead of string. I can say my other string example. And now I can set this equal to something else. Now, in this case, I have to set this equal to a string. Because I'm using the var keyword, it's not going to know the type until I assign it. So what happens here is it knows it's a variable because of the var keyword, and we know it's called my other string example. The type is actually implied. That's why we call it implicit typing. The type is implied based on the assignment. Now, the assignment has to be done right away. You can't do it later. And what I mean by this is it wouldn't be good to do this oops, I blew it away. Let me get it back. And then on this other line we say my other string example. There we go. And we'll do equals and then we'll paste it in. Okay, that's going to be a big no-no because since we're not setting it on the same line, it's not going to understand what the type is. And so it doesn't know, since we are still a strongly typed language, it's going to say, hey, I don't know what to do with this. So this is not what we want to do. We want to make sure that our assignment is on the same line as our declaration if we use this implicit typing. And it's a sort of what we call a form of syntactic sugar. It just makes things a little bit nicer. I don't have to type out variable types for everything. I can just type var and then assign it. And it's kind of nice because sometimes when you get down into the weeds and you're using, say, different types of collections, strongly typed collections, things like that, if you want to change what that is, you don't have to go through and change all of your type declarations. You just change the initial assignment, and it saves you a little bit of time. I personally like this. You can use whichever one you like. I have a lot of students coming through that are taking Java at the same time they're taking C#. And the only difference between Java and C# in this case would be a capital S in Java instead of a lowercase s. And so it's just a tiny difference between the two. So that is a string, and that is implicit typing. So let's take a look at some of the other types. So we'll do both kinds. We'll do an integer. This is a number between -2 billion. I always say -2 billion and change and +2 billion and change. You can look up the exact range. If you think that you're going to go over 2 billion, then you should probably not use integer. You should probably use something else. And so it isn't all that important that you memorize down to the last decimal point the size of these things. Just use a rule of thumb. So we'll say integer, and I'll just call this my whole number so that we don't have the word integer in there anywhere. Again, the name is completely arbitrary. The rules are that you can't use the same name twice in the same scope. You can't use an integer that's, or excuse me, you can't use a variable name that's the same as a keyword. For example, I couldn't create something like this. Ooh, I left off my semicolon. That's why it's being so weird. Here we go. So I couldn't use something like, I'll make an integer called using. And you can't do that. It's going to actually tell you you can't do that. Why is that? Because if you look at the top, you'll see that using is a keyword that's relevant to the C# language. I couldn't, for example, also call my integer variable. I can't call it class because, again, that's a keyword that's built into the language. So you can't use something that's unique to the language, and you also can't have it start with a number. So I can't say int 8 is great. That's not going to work either. So it has to start with a letter or a symbol, and it has to follow all of those other things. So it has to be unique within scope. What do I mean by within scope? If you look at these curly braces, you can see there's the opener, there's the closer. That's the scope for all intents and purposes right now. So I have to use the same, I can't use the same variable name twice within that scope. So we'll go back to creating an integer called my whole number. And right now it's not initialized. I always initialize my variables because that's a good thing. And since this down here in update is a different scope, I can actually do this again. I could say my whole number equals, oops, -5. And that's completely legal because, again, it's unique within scope. These two things are different scopes because they are contained within different sets of curly braces. So that's what unique in scope is really talking about. Now we have a range of -2 billion to +2 billion for our integer. So we'll say plus or minus 2 billion. But what if we don't need negative numbers? If you don't need negative numbers, there's lots of instances where you're not going to need negative numbers. For example, age. It's impossible to have a negative age. Experience points in a game. It's impossible to have negative experience points in a game. In this case, if you really don't need negatives, you can use what's called an unsigned integer or a uint. Just put u in front of it, and that's all you need to do. So I'll say experience points, like so. And now we can go all the way up to 4 billion and change. It's like 4.2 billion and some extra after that. So I'll just set this equal to some number, and now we can do just positive. There's no unsigned. Unsigned means no negative sign is really what it really means. 0 to 4 billion. If I can find my 0 key. There we go. So you can see that it's the same amount of space. Before we were doing -2 billion to +2 billion. If we take the negative sign out, we can go from 0 to 4 billion. And sometimes that's helpful. To be honest, you don't see people use uint very often. There's no real advantage to using it. I just wanted you to know that these unsigned versions of the ranges are available to you. But most programmers just make ints. They just say int, here you go. It's not going to be anywhere close to 2 billion, so it's fine. So if you're going to use age, you could use probably something like a short would probably be a better thing to use, but most people, I'm just telling you straight up, most people use integers for everything. That's just how they do it. All right, so those are the integers. Let's take a look at the other kind of number that we use, and those are floating point numbers, and you use these all the time in Unity. I would strongly suggest that these are probably more prevalent in Unity programming than integers are, just because it seems like everything in Unity is a floating point number, which means it has decimals in it. So we'll make one like this. We'll say float equals, we give it a name. We'll call it my float for the first one. And now we're going to give it a value, and I'll just set it equal to 0. Well, that's okay. That will probably work. But as I mentioned earlier, I don't like guessing. So let me show you something that you're going to see a lot of. We could make this a little bit better. We could say 0.0. Okay, now it knows that it's got a decimal in it, and Really, that's not for the compiler. That's for you or the programmer that comes in behind you to maintain this. But if you really, really, really want to be awesome, and of course you do, you put an F at the end, and that signifies that it is, in fact, a float. So you could do that. You could do it this way. And I'll do that sometimes when I get a little bit lazy. Putting that lowercase f there specifies that it's a float. It's just a hint to the compiler. That doesn't make it, an F, like a character F. It doesn't do that. It sees that float in the context and says, okay, I understand that is a float. There's no such thing as an unsigned float, so you're not having your range problems going forwards and backwards. The range for floats are pretty astronomical anyway, so it would be really rare that you would need to go bigger than that. Especially in Unity. Unity seems to favor things that range between 0 and 1 or -1 and +1. So you can do a lot with just those ranges. And I think that's probably on purpose because as you get into larger and larger numbers like doubles, now you're using up more and more memory. And so in a game, you want to be as concise as you can, or small in terms of memory footprint as you can be. And so this is helpful. So we've got our floats here. We can also use our implicit typing this way. So I can say my other float. And this time we really do need to hint at what it is. So we'll call it 0.0f. So when you're using implicit typing, you have to pretty much imply. Otherwise, it's not implicit typing if you don't imply. So give it every hint that it needs to get it right. All right, so the other one that you're going to run to, we did strings, we did the two kinds of numbers that you're going to see. The other thing that you're going to see is a Boolean. And a Boolean can only have a value of true or false. And true or false are keywords in C#. So it's really easy. I can say bool, my true value equals true, like that. And then I can change that to false later. If you want to use implicit typing, you can do it this way as well. We'll do false this time. There. And so that's what that looks like. So you're going to see bool, short for Boolean, and then the variable name, and then either true or false. Now we can cast these things to different types. So it's possible that you can make a Boolean into a 0 or a 1. But you can't go the other way. You can't easily go the other way. You'll note that a 0 or a 1 would fit into an integer, so it's possible to cast a Boolean into an integer. But if your integer value turns out later to be 3, 4, 5, 6, then you can't fit that inside of a Boolean. So you have lots of ways that you can cast when you're converting one variable into another one. The easiest cast in C# is converting anything into a string. So let's say that I wanted a string version of my experience points. Maybe I'm going to put that on the screen in my user interface, and it needs to be a string. In truth, I tell you that C# will do a lot of these casts for you automatically, particularly if you're casting something to a string. But I'm going to show you how to go ahead and do it explicitly. So let's say string version of experience points. How about we do string XP, because everyone knows XP is short for experience points. If not, you do now. We'll say var string XP equals experience points. Forgot my equal sign. Dot toString. And this is available on almost every object. You get this toString method. What it does can be different from time to time, but most of the time it's going to convert whatever that is into some sort of string representation. And in this case, it's going to take a floating point number and it's going to convert that. Actually, I'm sorry, it's an unsigned integer. It's going to take that and convert it into a string, which would be suitable for putting it into your user interface, your heads-up display, whatever you'd like to call it. So that's the easiest cast in the world. There are a few other ways that you can cast things, but you do have to be mindful that things don't fit inside of other things. And we have this slide in our lecture where we've got those Russian nesting dolls, and obviously the biggest doll won't fit inside the smallest doll, but the smallest doll will easily fit inside the biggest doll. And if you look at how the types work. The smallest one is Boolean. Boolean can fit into an integer. Integer can fit into a float. Float can fit into a string. And so anything going up is okay. Coming back down is going to give you problems. You have to really be careful if you find yourself needing to do that. You might want to see if there's a different way of going about it, like making your own type. Making your own type is for another day. We're just doing basic primitive variable types at this stage. All right, so I'll show you how to cast from one to another that isn't as simple as .toString. There are a number of different ways that you're going to see it. So what we can do, for example, is we can, let's say we have, we already have one. We have string XP as a string. How do we convert it back into experience points? We can say experience points equals, and now we could set it to string XP, but that's not going to work, right? Because it's not going to work. It's a string here. How are you going to get a string back into an unsigned integer? Well, what we can do is we can use one of the casting methods. So we can say uint.parse, and then we'll pass it string XP, and now it will convert that back into an unsigned integer. And this works for everything. You'll have int.parse, you'll have float.parse, bool.parse. They all have a .parse object in them, or a gosh, that's hard to say, a .parse method in them. We haven't covered methods yet, so we're getting a little bit ahead of ourselves, but I did want to show you different ways of casting. Now I'll show you a couple of other ways that might work, and you're going to see these in different contexts. So let's say that we have an unsigned integer again. You're going to see it done this way. And I'm not entirely sure that that would work. There are cases where it will and cases where it won't. I'm showing you the formats. So if you see a type in parenthesis next to something, what that's doing is it's casting it to that type. Another way that you'll see it is like this. Oops, it didn't like that. So sometimes you'll see, especially in method return types, string XP as uint. So if you see the as uint tacked onto the end, then know that it is casting it. So those are the ways that you're going to see with respect to converting things one to the other. It seems like there's one other one. I think it's the convert class. Nope, I guess not. Well, the three are good enough, right? So those are the three main methods that you're going to see changing one type to another. And there is, you might have noticed there was a try parse in there too. That's a better way to do it, but we haven't really covered methods yet, and so I want to save that for a little bit later. But these three are the three that you're going to see fairly often. So that's it for our variables lab. We've gone through everything that we discussed in the variables lecture, and now you are ready to move on to functions and see if there is a variables quiz for you to take. There should be.